Let's move on to our next speaker, who is Denis Zaytsev. He'll talk to us about INDIHUB, the network of backyard telescopes and citizen science platform. Take it away, Denis.
Hello, everybody. Thank you very much for inviting me to such a great event, the online evening meeting. This is going to be my first talk today at the Astronomical Society. So let's see how it's going to work for me. So today I'm going to present to you my project, INDIHUB, the network of backyard telescopes and citizen science platform. Okay, let's move on. So because it's my first talk, I thought it could be a good idea to introduce myself. So just a little bit about my background and context, how I reached that point in my career building projects like INDIHUB. So I'm a software engineer with 18 years in IT. I'm self-taught in astronomy, self-taught in astrophotography. I'm not trained as astronomer, but I'm thinking about it, to be honest, sometimes. I'm very interested in astroinformatics. Astroinformatics, it's a new branch of informatics when you basically join their data science and artificial intelligence with their astronomy and astrophysics. And I believe that's the future. Eventually, I'm very interested in robotic telescopes. That's what I'm trying to build, the network of robotic telescopes. And that's basically what INDIHUB is. My favorite deep sky object is M11. My favorite solar system object is Mars. I live in beautiful Aurelia, Sunshine City, in Bortle class 5. And again, I'm founder of INDIHUB. And on the right, you can see my setup, one of my telescopes, which is pretty typical for the backyard observatory. Okay, first topic in my talk is what is INDI? I would ask audience, please type in the YouTube chat answer to question if you ever heard about INDI or you already use it. That would help us a lot. And they're just interested in how popular is here among our audience. So INDI is a software library to control astronomical equipment. That's pretty easy. When you buy equipment, you assemble your setup, mount, telescope, cameras, or autoguider, many things. You need to control them. And believe me, it's not easy. So INDI, based on special protocol, which stands for Instrument Neutral Distributed Interface. I know it sounds scary, but the protocol is actually very easy. It's a XML-based protocol, and you can program for it easily. Also, INDI is open source project with a big community. And big community includes developers and backyard astronomers, astrophotographers, even academic institutions. And I like to think about INDI as a software library built by astronomers who also actually working in IT. So it's very user-friendly product and stack of technology. INDI has a big driver library. That includes equatorial and azimuth mounts, CCD cameras, motorized focusers, of course motorized mounts, motorized filter wheels, spectrometers, motorized domes, weather stations, and controllers like joysticks to control your mount. So everything is covered there, and the best thing about it, thanks to their INDI protocol, when new driver is developed for say something new in the market, some new device, some camera, and added to INDI lib stack, all your client software can use it immediately. It's available immediately. You just upgrade INDIHUB and that's it. Access to equipment is abstracted via a network server. Clients talk with server over INDI protocol. So this is very interesting concept, and it's very, very easy to understand concept. You have server running on the side from your equipment, and to control this equipment, you just need to know how to talk to that server, which is pretty easy from point of view software development. And another thing worth to mention, of course, lots of graphical user clients. Really, there are lots of interesting software, and I just put some of them here, which eventually is K-Stars Echos, also apt or astrophotography tool, PhD tool, which is auto-guiding software. It can also actually control INDI devices, sky charts, PixInsight, and many, many more. So on the right, you see their indihub.org. That's their address of website. If you want to learn more, just go to that website. And also, I put a little screenshot here. That's actually K-Stars Echos with imaging session for M42 in progress. You can see how it looks like. Another thing I wanted to mention about INDI, they have really good forum, very friendly, probably the friendliest forum I've ever seen on the internet. You can get lots of help here, and just register there, ask questions, you'll get replies like the same evening. Okay, let's move on. What is INDIHUB? INDIHUB is a pretty green project. It was launched in February 2020, this year. As I was saying, it's a network of telescopes powered by INDI technology. INDI is a bare-bone technology for the INDIHUB network. At this time, we already have 72 telescopes registered on the network, and it's still growing. So the network is live and breathing, and this is a very interesting moment to watch it. And also, in terms of features, the core feature of the INDIHUB is equipment sharing. I will be talking a lot about it today. Basically, the flow is you, as a host or owner of equipment, run INDIHUB agent and switch it into share mode. And then, guest you want to invite to use the equipment receives invite and connects remotely to equipment with INDI client. Again, INDI client would be anything like our K-Stars Echos and many, many more. And they're available for macOS, Windows, Linux, or you name it. All traffic, imaging material, as we like to name it, goes through the INDIHUB relays in the cloud. And the cloud runs on AWS. My motivation to start this project was just time when I had lots of cloudy nights, and maybe 6 weeks in a row I didn't have any clear night, and I was thinking that would be so cool to connect somewhere and just to do imaging. And it doesn't matter, is it North America or Africa or Australia? Of course, Australia would be much more better for me, but I just wanted to do some imaging, but I couldn't. So all I could do is just working with existing imaging material and reading books. But then I realized, wait, their INDIHUB has a network nature, and that means we can actually build a network. And I can actually use other people's equipment, and they're willing to share. And then I can provide access to my equipment, and they won't, as reply. So that's how IDEA was born. Okay, so let's speak about INDIHUB agent modes. So INDIHUB agent is a core component, and this is something the owner of equipment runs to be part of the network. It is a software which is running as a sidecar together with INDI server. And the first mode is share mode. You can see, by the way, on the right, the screenshot of INDI Web Manager, which is part of INDI Stack. You just run it to control your INDI software. And you can see that you can easily switch through the interface, the mode, in this case to share, and then you can see the confirmation, and that would be your address you want to send to your guest. And this connection string will be used in client software by guest to connect to your equipment. So it's pretty straightforward. Share mode just shares your equipment. Solo mode. This is a little bit different. Equipment is controlled only by you. Well, it's very different, sorry. There is no more sharing. In this case, you use your equipment as you usually do. You do imaging, observation, anything else, but all images are still contributed to INDIHUB. So are willing to contribute and send your images, and it's done transparently over network. You don't see how it's all going. So it's your user experience is not influenced in any way. And the third one, which is experimental, we are still working on this, it's robotic mode. This is when you want to share your equipment with network without sharing with person. So you're contributing your equipment to the INDIHUB network as artificial intelligence scheduler, and it's performing different tasks for science projects. So in the future, we'll be accepting requests for follow-up observations, for instance, and you can participate contributing your equipment for this robotic mode. Okay, let's move on. Sharing equipment and remote access benefits. Well, benefits are that observations and imaging sessions could be done from different geolocations. For instance, southern hemisphere. And you can see on the right, I put picture. This is their image of the sky from the Australia or close to Perth, Western Australia. This is something we in Canada will never see, unfortunately, unless we travel to Australia. So with the INDIHUB network, it's totally possible if you find a host in Australia and just do your imaging remotely. Another benefit, there is no need to travel with heavy and expensive equipment. You don't have to anymore. You can just connect remotely, which effectively teleport you to that geolocation over internet. You can try different equipment and setups without buying this equipment or before buying it. You can just find someone with equipment you want to buy and try it, you like it, you buy it. And that prevents lots of pricing mistakes, I think. Another thing, when you have a cloudy night, there is always a clear night somewhere. So that means less cloudy nights and clear skies can be always somewhere. And also you can connect to the most distant locations with close to zero light pollution, and you can actually experience the sky you've never seen. Unfortunately, this is the world we live in. So that will be possible as network grows and we will have more distant locations connected, and eventually you're going to see that. Okay, let's move on. Let's speak about INDIHUB as citizen science platform. So by design, all imaging data is going through the INDIHUB relays, and this is going to be lots of data. INDIHUB platform already has an image processing pipeline in the cloud, which consists of stack of technologies like Python, OpenCV, which would be your computer vision AI, and we run our own stack of astrometry.net servers for plate solving. This pipeline extracts data from images and annotates them, and they will be extracting lots of data, and INDIHUB as a platform will be providing this data as open API for all third parties interested. And the cool thing about all this that you're going to be participating. Users will be able to see what was discovered on their images or in which third-party projects actually your work, your images are used. Also, users will be able to receive tasks from INDIHUB platform and participate in different science projects, say follow-up observations or just some tasks connected with their tracking of asteroids, near-Earth objects, and etc. This is very interesting because your regular imaging night turns into actually contributing to science and planet defense. We'll speak about it a little bit later. And there is totally different level, of course. And that applies to any kind of session, share session or solo session over INDIHUB. The imaging material still gets transferred to INDIHUB platform and into the cloud. So let's speak about projects we have right now in the pipeline and they're under development actually. So I want to tell you about Trusad.org project, which was launched about 6 months ago. Trusad.org is a citizen-powered, again, open source system for creating a trusted database or records of satellite orbital behavior. Trusad software merges observations of satellites from around the world into transparent record of its location. We have, on INDIHUB side, millions of images with satellite trails, and everybody hates them, I know. And they're not used, especially images from auto-guiding cameras. They just used to guide your mount and compensate their periodic error on your motorized mount. But these images go to nowhere, many of them. Typically, you set exposure for auto-guiding camera 1 second or 2 seconds. So that means thousands of images for one imaging session just go to nowhere, but actually they contain satellite trails. You can see on the right here, that's your typical image from auto-guiding camera, satellite trail. This is very valuable piece of information because by this image we can determine what is the satellite and their actual data for orbit determination. And then we can send it to Trusad. And all images are precisely timestamped, have geo-coordinates, and they have elevation above the sea. So INDIHUB is a perfect data source for Trusad. And just a remark about their satellite tracking, it's maybe you would ask, why should we do this? Well, we live in the world when low Earth orbit objects are growing exponentially, and it's busy there. And the purpose of services like Trusad is to introduce censorship-free and independent source of data, what's going on there. And it's very important to watch satellite operators because right now, as far as we know, in many situations, when they have to follow some rules or instructions, they're actually powered by business decisions. Because every time you do maneuver, satellite maneuver, you actually reduce the operational lifetime of this satellite. And in many cases, it's a business decision. And unfortunately, that's just rolling the dice. So these kind of resources are very important because we are reducing the amount of junk around our planet, and it's just first step for space sustainability, space sustainable exploration. So let's move on. Another project which is under development right now is integration of INDIHUB with MPC, or Minor Planet Center. So as we were saying, INDIHUB image processing pipeline is already working, and it does plate solving. Okay, we have some sorry messages. Sorry, I got distracted. So INDIHUB has this pipeline which does plate solving and identifies moving objects on all images taken by hosts on the network. And on the right, you can actually see a very typical image with a moving object, which is likely asteroid or near-Earth object. What's next? Then astrometry data is calculated for all moving objects found. Think about well-known astrometrical software, but running in the cloud. Then all images, they're precisely time-stamped. So INDIHUB is a great source for observations for MPC. The observations for MPC is actually astrometric data of these moving dots in the sky. And they're very interested to get them. Why does it matter? Well, ask dinosaurs. I'm pretty sure they would explain you in very detail. Unfortunately, they couldn't. Discovery credits. You will be observer, and INDIHUB network will be measured if you find absolutely new object. This is something we still need to discuss with NPC guys, but this is how we see it here at INDIHUB. And again, it's very important, and just think about it. You could actually prevent a very big disaster just doing your imaging session, potentially, you don't know. Or you can participate and you can help NPC to recalculate and clarify orbit elements for all asteroids found. And it's very important because asteroids need to be tracked constantly. They're not stable in most cases, and the orbit elements need to be justified every time we see them. And the more earlier we found that some asteroid or near Earth object is dangerous for us, the better, because it is the only disaster we can actually prevent, natural disaster. And only if you know it as early as possible, like years before it happens. And again, there is no question that their Earth is going to be on collision course with asteroid in the future. The question is when. So you can participate in this very important project, and your imaging session might tune into a very important flow here to help defend our planet from their enemies. So that's pretty much it. I just wanted to talk a little bit of the current state of the project. I think I still have some time. And what is next? So network is growing naturally. You don't ask people to sign up or do any kind of registration. It's open sensor approach. You run the INDIHUB agent, you appear in our network. Equipment sharing and remote access is already implemented and it's being used actually. This is exciting time because the things I was thinking about 6 months ago right now are real and they're actually used by people. Integration with Trusad, it's under development. On that front, we still need to do some work. Integration with MPC, Minor Planet Center, also under development, but we'll get there. Also, INDIHUB Web UI is going to be released soon. This is going to be their web interface to control your equipment right from the browser. And it's going to be one-stop shop to control your equipment or to control someone else's equipment if you invite it as a guest. All from browser, and everything will be done without any software. That's a sneak peek to INDIHUB Web UI. I just wanted to provide it. I know it looks pretty rough, but here we found the object Polaris. You can see that we actually connected to the equipment, guiding camera, main camera, motorized autofocuser, and motorized equatorial mount. And we actually did go to and in tracking mode, and our next step would be that camera icon. Just run your imaging sequence on the object, and that would be basic flow on our web UI. All right. Before questions and answers, QA section, I just wanted to mention that don't forget to go to our website indihub.space. If you have any questions, just drop a message to me to this email address. Our GitHub is here, and you can follow us on Twitter. Plus, you can actually sign up for updates on our mailing list on the website. Okay, thank you very much for listening to me, and in case of any questions, I will be happy to answer them.
Denis, thank you very much for presenting to us. This is an amazing project that you're undertaking, and we definitely wish you great success. And I guess we need to help you spread the word because it's all user-based, so the more the better.
Exactly.
Let's go to Q&A then. Ennio, any questions?
Yes, we have a couple questions from Blake, and I'll post them one at a time. First question, what sort of citizen science is being done right now?
Citizen science right now is, again, two projects which are under development. One is Trusad, or satellites tracking. If you go to the trusad.org website, they have lots of information, and actually tracking of satellites can be treated as a game or as a sport. So INDIHUB will help you to do this just by imaging and doing your astrophotography on the go. Another project is integration with MPC. So in future, not right now, if you're a user of INDIHUB, you will be able to receive tasks from INDIHUB to track different asteroids, which you would be able to see tonight, or track near-Earth objects. Or MPC has a special list of objects nobody knows about, and they need more data about them. That's probably the most urgent task. So this kind of science projects, citizen science projects, will be able to do. And in the future, we can think of many things, like I've seen on Cloudy Nights forum, some guys actually were able to do search of exoplanets just using our pretty standard equipment. And there's some special software. Potentially, we could do this as well on INDIHUB. And there are many tasks connected with just light pollution or tracking passenger jets, for instance, or many, many interesting things, which probably be implemented in next year, not right now. Right now, we are more focused, again, on integration on Trusad, tracking satellites, and their integration with MPC to track asteroids and near-Earth objects.
Awesome. Second question from Blake is, what are the storage capacities of the system? Because you're capturing a lot of image data.
Exactly. Well, I wish I could say that storage capacity is unlimited, but I cannot say this, of course, for obvious reason. But fortunately, our INDIHUB is implemented on AWS, Amazon Web Services cloud platform, and there is a special service, S3, which is very, very cheap storage. And you can store there terabytes of data and still paying almost nothing.
Interesting. And I myself have a question. With the Minor Planet Center that you guys are working with, have they released some sort of an application programming interface to access their data? Are you guys somehow affiliated on the back end somehow?
That's a good question. Yes, the MPC has a whole bunch of APIs to access their data, ephemerals, and everything you want to search in our solar system can be done via their API. Also, they have special API, which I believe was introduced maybe a couple of years ago. I might be wrong, not too far away, I think. That's a special API to submit observations. Before that, to submit your observation, your astrometry as a observer or owner of the observatory on your backyard, you have to send email to them, specially formatted. And if the format is wrong or you miss some little space or new line symbol, that's it. It's not valid. So it was pretty tough process. Right now they have HTTP API where you can actually submit programmatically your observations, and it's quite nice. So this is exactly what we're going to use at INDIHUB.
Any more questions, Enya?
You don't have any at this moment.
Okay, very good. Thanks again, Denis. Fantastic project, and perhaps you could come back and give us an update, I don't know, a year from now or so. So keep in touch.
Thank you very much for having me. I will come back, no worries.
Excellent.